All right, welcome to Unit 7. We're going to start obviously from the beginning with Lesson 1. Um, our lesson today is going to be on periodic functions. Now, when you see the word periodic functions or the phrase, hopefully you notice functions, right? So that's something we know we're going to probably be dealing with some graphing, looking at that. And then you have the word periodic, okay? And so we're going to kind of unpack that in this video, and then in the next video we'll look at features of the periodic functions, talking about things called cycles and periods before we turn you loose. So let's get started. All right. So it says, let's come up with a definition of periodic function. Well, so we have some examples here, right? So we've got an example of let's look at the non-periodic functions first of all. So these are things we kind of know, right? This would be something probably to degree 4, y equals x to the fourth plus blah blah blah, right? You get your zeros that go through it. Its end behavior here is going up to positive infinity. This goes, and the end behavior as x goes to positive infinity is that y goes to positive infinity. Here we got a linear equation, positive slope, starts negative, winds up positive. And then here you got some kind of crazy thing that looks like it kind of dwindles down to nothing, and then when it gets here, it slowly gets bigger and bigger and bigger, right? So these are examples of things that if you think of the word repeat, right? That's kind of what period implies, right? And this does not repeat. This does not repeat. This does not repeat. Like they kind of have, depending upon where you go in the graph, you're going to wind up at completely different parts, right? Whereas if you look over here, these are repeating functions, right? This thing starts here and it goes up here and blah blah blah, and then it stops here and then it starts over again, and it will continue to follow the same thing. This is the same thing. It's got a slightly different pattern. Looks like it goes up high, goes down low, comes up here, and then does one little more low swoop before it starts that pattern over again, right? And so all these have kind of different patterns here. This one has a kind of a weird like sideways staircase sort of pattern that it starts from like, here to here, right? This one would be like from here to here. This one would be like from here to here. I mean, it doesn't matter really where you start it. We're just picking the easy ones. This one, it looks like, here starts, blah, 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 stops right there. So it's not continuous, right? It's discrete, but it's still a periodic function. So hopefully you're recognizing that the periodic functions, the big keyword there is repeats. So the way we're going to define this is we're going to say that this is a function that repeats itself at regular intervals. All right, that means it does it consistently. It doesn't repeat itself like once or twice. It continues to repeat itself. All right, and you could even say that it repeats itself, infinitely. As it doesn't stop repeating itself. Right. None of these show any indication of stopping. Right. They're going to continue to do their thing, and because you can have a function that might repeat itself, like it looks like it's repeat itself and then it does something else, right? But these are ones that repeat themselves at regular intervals and continue to repeat themselves. All right, I'm going to write that a little bit, and continue to repeat themselves. All right, so that is what makes a periodic function a periodic function. The word period, right? If you think about that and how that relates to school, right? So if you have a period, it's like we know that every day from this time to this time you will be in this class, and that's why we call it period 2 or period 3 or whatever it is, right? Because you can count on it and it's going to be a regular thing. And so that's kind of what a periodic function is you can kind of predict where it's going to be depending upon what your x value is. You can tell what your y value is going to be based on that. So not a super hard concept to see, right? A little harder to explain than it is to see it, but hopefully seeing it, this makes some sense to you. So we're going to stop the video here, and then in the next video, we're going to talk about a couple pieces of vocab and then start doing some of these.